So this is just a test. This is my semi-working RISC-V CPU simulator. My main objective is to teach how computers really work. I think there's a huge gap in teaching properly for a beginner to understand. I also struggled and continue to struggles about learning how computers really work, and for today is been fascinating for me. I learned a lot of things, so in the meantime, as I learn, I make this simple CPU simulator. More features are coming. My ideas that I have come to my mind is never ending, but to implement them properly, it's take time. So this is my first version that I finally can show something useful to show. So I have the registers section, all the 32 registers that RISC-V CPUs have. The memory is 64 kilobytes, and I divided in 3 sections. I think is the most. We can divide it into more sections, but these 3 is the absolute essentials to for a beginning to learn. So we have the text section, but it's not text to store, but the actual CPU instructions are stored in this section. Then we have the data section. So this section is usually for storing variables, and you can see already here. And the stack we talk later, but is one of the most essential things for function calling and other things that I still need to learn. So let me stop the fluff and show what this little program does. So it has 1, 2, 3, 4, 5, 6, 7, 8 instructions, just 8 instructions, and it can print text to the terminal. In this case, so it has an highlighting for where the program counter is, which instruction is executing, and this little program copies each byte, so in this case each character from this memory location and forwards to print my name, and that's about it. So to better understand this, so we can reset all and just step one cycle of the time. So the first instruction loads the address for the terminal. So in this case, if you store data, store in asterisks for this memory location, so F000, it talks to the terminal. So every byte you send to this address, the terminal will spit out if is according to the ASCII table. We have here the ASCII table, and each character has one ASCII character, and so the RISC-V CPUs can only manipulate data when it has on the registers. We cannot simply call from directly from memory. You have to put everything on registers and then process the data. So the first instruction is to put the correct address to talk to the terminal. So we go another step and it puts another address in another register, in this case T1, and that's the address 8000, and the address 8000 is exactly where the first character is. So this one, the capital letter S is on the address 8000, so it's +0, and the lowercase letter E is 8001, +1 and +2 and +3 and so on. So we step another time, and as you can see, this instruction loaded into the register T2 what is stored in the address 8000, and this case is the hexadecimal value of 53, and in this case in the ASCII table represents the S key, the S character. So as you can see, X and 53. So now we have the letter S loaded into T2 register. So then in the next instruction, this instruction tests if this character is 0. So we can know if we reach at the end of the string. If you program in C, you know that normally when you printf or something like that, or the string character to tell the CPU this is the end of the string, we test if the last character is in hexadecimal 00000. So this one tests that. So in this case it's not, it's 53, so it goes on, and now they store, in this case this instruction stores this value on this address. So right now the simulator is still only shows the hexadecimal value of the instruction, but if we go to translate this hexadecimal character, we know this is the instruction to store data, and this case it will store in this address F0000. So is go again, tests the code and goes up. This case doesn't test, this just jumps straight up to this address again to load another character. In this case it increases to the T1 and loads the next character, this case 65. Goes another to test and then prints out. So that's it. So you can go a little bit faster because it's always the same. And we reach the end, and now we'll go to C the E. Right now is on the E, and in this case will be 0. Now, as you can see here, is now 0. So when it tests, is this register equals to 0? If yes, go to the end. And as you can see here, it jumps right to the end. And this is just a loop to jump to itself, so it doesn't do anything more. So I hope you enjoyed this very brief explanation of my early stages of my RISC-V CPU simulator, and we see in the next video with more updates and more explanations and my better English. I need to practice more. Thank you.